Long story short, I was involved in a project that revolved around building a soil-powered water purification system. It was a very first proof of concept that was meant to show you can actually power things with soil, and I was in charge of the whole engineering and development side of things. And at the end of the project, we went over to Brazil to help the local communities there access drinking water in a safer way. What they were doing at the time was they were collecting a lot of the rainwater and then dumping chlorine into their rainwater tanks, and that was their way of treating it, making sure it's safe to drink. And reality is that if it's done in an uncontrolled manner, adding a lot of chlorine can lead to generation of a lot of toxic compounds. So what we wanted to do is offer them a more sustainable and safer alternative, and also have it be powered by soil, because the region there, particularly where the case study was based, also struggled with access to reliable power. And I mean, the findings were, we've proved that this technology can actually work. We've got very similar results to what we obtained in the lab at the time. The tests, of course, revealed a lot of weaknesses, which was a good thing for me, because then in my PhD I had quite an easy job of knowing what needs improving and what to focus on with all the engineering that I was doing. One of the big lessons, I think, and the unique thing about this technology was when it comes to the user interaction with it, the adaptability, the sort of behavioral and psychological side of things. So what we did is we worked with kids from a local school. They were helping us build these prototypes and install them and operate them. And it was quite fascinating to see how easily they were managing to grasp how to do it. And the reason why that's so unique is because with other technologies, for example, like solar, a big part of why a lot of these projects fail in trying to introduce tech into developing worlds is because you don't have the expertise there to build these devices and maintain them. Whereas with this technology, simplicity is key and a big selling point for us, and we saw the evidence there. Then for me, it was the moment when I saw what I did in the lab being transferred into the field that really made me fall in love with science, and not science for the sake of science, but science for the sake of impact. And pretty much that moment then shaped my next 4 years of my life and made me do a PhD. And during the PhD, I already knew that I wanted to start the company and turn the research into a real world product. Nikola Tesla basically dreamed of a world where electricity can be, transmitted without wires, without any complex infrastructure, and made accessible pretty much to anyone, anywhere. What he believed is that you can use the soil or the ground as a conductor to transmit power wirelessly. There's a movie called The Prestige, where there's that iconic scene where you have Nikola Tesla's field full of light bulbs that are lit up by just being put in the ground, which nicely conveys what he was trying to achieve. What Tesla didn't realize at the time is that not only can you use soil as a conductor for electricity, but as an electrical power source. And that's what we're doing at Bactery. We still have the same mission and ambition of making electricity as accessible as it can be, but with a slightly different approach. And that's because of all the biological processes happening in the ground. So right beneath us, there is a microverse full of microbial life. And in order to thrive, these microorganisms, they consume organic molecules. And some of them are capable of consuming these molecules, and during that, they release electrons. And what we've essentially done is figured out a way how to tap into these bioelectrochemical processes and give these electrons a pathway to escape. So we're essentially capturing them and driving them out of the ground in form of clean electricity. Yeah, so there are a few reasons why we're looking at Agri IoT. First and foremost, we've identified that there's a legitimate problem there. So if you take a look at the current pace at which we're trying to smartify farming, it's a lot slower compared to other industries, and it's largely because of the issue of energy infrastructure, or their lack of. So, what we want to do is essentially help break that barrier down. The current solutions that exist are simply not good enough. They're not compatible enough with the agricultural environments, which means they're costly and very maintenance heavy. The other issue is power standardization. Right now, a lot of these IoT devices come with different power sources, and if you can imagine having to, look after several hundreds of devices on your field, and each one comes with a different set of maintenance instructions, things get overly complicated and just impossible to scale. So what we want to do, and we know that the sector is in need, not just for any power source, but the power source that's simple, safe, and reliable. And we think soil would be the perfect solution. And then I would say last but not least, the reason why we want to start with Agri IoT is because we're in a very privileged position to be already close to the market with our product. Our Generation 1 Bacteries are already capable of generating enough electricity to sustain most of these devices out on the market, which gives us this advantage of being able to already hand this technology over to people, to customers, to clients, and have them interact with it, have them break it, tell us what's wrong, what's right, which I think overall is going to help us accelerate the developments, but also establish a very strong foundation to build on as a company. I would like to see Bactery entering the renewables mix and actually turning soil into an energy alternative, not just for the low power applications, but for the bigger impact as well. So down the line, what I'd like to see is people being able to use this technology anywhere, not just to power IoT, but to power their homes or power their appliances. Because right now there's still many, many people out there who don't have access to electricity at all, or have to rely on very harmful fuels in order to just do everyday tasks.